Hello everyone and welcome back to Newton's Academy past paper review. Today we'll be covering the physics topic impulse and momentum, and we'll be doing question 4 of this past paper. Looking at the question, they give us the momentum versus time graph of object A originally moving east, and they show us the graph below. So they already told us that the object is moving east, and we can see that the object starts off with a positive momentum, and since momentum is a vector, we can infer from this graph that the object is the momentum is positive when it's moving east, so it's moving east. Once momentum becomes negative, that means its direction has changed, so it's now moving west, and it changes once again as it becomes positive, so it moves east again. And they give us the time intervals and certain momentum values. 4.1 asks us to write down the definition of momentum in words, and with all physics questions they usually ask at least one definition or one law or one principle for 2 marks. So you simply swap these off and you state them, and you get that counts for quite a significant percentage of your paper, so you should try your best not to lose marks in the definitions questions. So I won't write this definition down, but I will state it. Momentum is defined as the product of the mass and velocity of an object. So that is the definition of momentum. Question 4.2 tells us the net force acting on object A is 0 between time equals 10 seconds and time equals 20 seconds. So between this point and this point. And then they ask us use the graph and a relevant equation to explain why the statement is true. So they're telling us the statement is true, and we have to prove it using the graph given and using a relevant physics equation. So using the graph given, we know that the graph is momentum versus time. So just writing that here, we have momentum and we have time. So the gradient of this graph, let me write underneath here, 4.2, the gradient of this graph, gradient is given as delta y all over delta x, will be the change in momentum all over the change in time. Why? Because our y variable is momentum, our x variable is time. And from our physics equations, we know that the change in momentum over the change in time, or in other words, the rate of change in momentum of an object, is the net force. So that means we need to look at the gradient between the time equals 10 seconds and the time equals 20 seconds. And if the gradient is 0, that means our net force is 0. And we see that since it's a straight horizontal line, the gradient will be 0. Therefore, our net force is 0. So that's using the graph. And using the relevant equation, again, we're going to use the same equation. So we have the net force, F net is equal to the rate of change in an object's momentum. And from this graph, we see that, let's just change the color. Okay, from this graph, we see that the object's momentum there is 50, and the object's momentum at 20 seconds is also 50. Therefore, the change in momentum is 0. Just change the color once again. So the change of momentum is 0 over the change in time, which means our net force will be 0, and therefore the statement is true. So that is the 2 methods we use to prove that the statement is true. Question 4.3 asks, calculate the magnitude of the impulse that object A experiences between time equals 20 and time equals 50 seconds. Now, impulse is basically the change in momentum of an object. So if we want to calculate the impulse of this object, we need to calculate the change in momentum of this object. So impulse is change in momentum, which means it is the final momentum minus the initial momentum. So let us go see. They wanted between time equals 20 seconds and time equals 50 seconds. So at 20 seconds, the momentum is 50 kg meters per second, and at 50 seconds, it's negative 120. So we start off with the final momentum. So it's negative 120, and we subtract the initial momentum, which is 50, and we get our impulse or our change in momentum to be negative 170, and the units will be Newton seconds, or alternatively it can be kg meters per second. Okay, so that will be our impulse. Question 4.4. At time equals 50 seconds, object A collides with another object B, which has a momentum of 70 kg meters per second east. So object A, we can see its momentum is negative 120, meaning it's moving west. Object B has a momentum of positive 70, which means it's moving east. They tell that to us. Use the information from the graph and the relevant principle to calculate the momentum of object B after the collision. So they want the momentum of object B after the collision, and they want us to use the graph and a principle to calculate this momentum. So for 4.4, the principle that we will use is the principle of conservation of momentum. Why? Because we have two objects and momentum will be conserved. Momentum is conserved in this scenario. So we use the principle of conservation of momentum for the two objects. And the principle of conservation of momentum tells us that the sum of the momentum of each object initially is equal to the sum of the momentum of each object at the end, which means the initial momentum of object A plus the initial momentum of object B will equal to the final momentum of object A and the final momentum of object B. So let's look at our graph. The initial momentum of object A is negative 120, and they give us the initial momentum of object B to be 70. So we can go fill that in. Negative 120 plus 70 equals, and we don't have the final momentum of object B because that is what we are trying to solve, and our final momentum of object A is 50 kg meters per second. So we simply fill that in, and then using our rules of algebra, we solve for the final momentum of object B, and we will get that to be negative, or not negative, rather positive. Oh yes, negative, sorry, negative 100 kg meters per second. Okay, and therefore, since momentum is a vector, the final momentum is equal to 100 kg meters per second, and we indicate the direction. It was a negative, so that will be west, not east, west. Okay, and that concludes our question 4 on impulse and momentum. Thank you for watching.